welcome you to the new practical, a study of overcurrent relay. In this practical, under the theory part, we are going to learn about the function of overcurrent relay, types of overcurrent relays, relay coordination of inverse overcurrent relay, and working principle of electromagnetic inverse overcurrent relay. Then we are moving to the procedure. So let's learn the theory first. In your industrial training module, you were in power stations and grid substations. There you would definitely observe the relay panels. One of those relays is what we are going to learn here. It is the overcurrent relay. You can find out overcurrent relays in grid substations, primary substations, and places where overcurrent protection is needed. So how does the relay operate? What is the function of relay? The protection systems consist of circuit breakers, current transformers, and relays. Current transformer transforms the primary current into a smaller current which is called the secondary current. This current is taken by relay. If this current exceeds the pickup current of relay for a specific duration of time, the relay will operate and turns off the circuit breaker to cut off the current path. There are basically three types of relays according to the time current characteristic curve. They are instantaneous overcurrent relay, definite time overcurrent relay, and inverse time overcurrent relay. Instantaneous overcurrent relay is named as definite current relay as well. This operates instantaneously when the secondary current which comes to relay reaches the pickup value, and then it trips off the circuit. In definite time overcurrent relay, it allows adjustment of operating time according to the current level. But once the current exceeds the pickup value, operating time will be independent of the current. That means no matter how much the current increases, the operating time will not be changed. Relay can be adjusted to trip the breaker nearest to the fault in the shortest time. In this purpose, definite time relay has two settings. First, the current setting, which is known as pickup setting, plug setting, or tap setting. This setting allows to select the current value at which the relay will start responding. Second, the time dial setting. This allows to obtain the exact timing of the relay operation. Inverse time overcurrent relay is also referred as inverse definite minimum time relay or shortly ITMT relay. As you can see in the curves, relay operating time is inversely proportional to the fault current. According to the characteristics of the inverse time curve, there are three categories. First, normal inverse. Second, very inverse. Third, extremely inverse. As in definite time relay, relay characteristic curves can be adjusted by selecting two parameters, current setting and time dial setting. Modern relays usually combine different curves in one housing. Then we are moving to relay coordination of IDMT relay. Relay coordination means the tripping of relays in a sequence in electrical power system. For an example, as you can see in the figure, for a fault beyond A, relay A should be operated before B. This can be achieved by adjusting the relay characteristic curves using plug setting and time dial setting. Plug setting, which is also known as pickup setting or current setting, refers the pickup current of the relay. Using this pickup setting, we then express the fault current as a multiple of pickup setting in the characteristic curves. This multiple value is called plug multiplier setting or shortly PMS. PMS is equal to fault current in the secondary of CT divided by pickup current. Time dial setting is also referred as time multiplier setting or TMS. It adjusts the time delay before the relay operates whenever the current reaches a value equal or greater than the current setting. Another term is time discrimination. It is the operating time difference of inverse time characteristic curve and definite time characteristic curve for a specific current value. You can see it in this diagram. Using these PMS and TMS values, we can calculate the operating time of relay using this equation. The moving system of overcurrent relay consists of two magnets, a damping permanent magnet and a driving electromagnet. The aluminium disc is fixed on a vertical shaft and rotating on two jeweled bearings between the poles of two magnets. The winding of electromagnet has 7 taps which are brought on the front panel, and the required tap is selected by plug setting. When the secondary current of CT exceeds the plug setting, the disc starts rotating and moving contact which is connected to vertical shaft is also begins to rotate. The initial position of this moving contact can be adjusted using time dial. Then this moving contact rotates and hits the flag, and the relay is operated. Now, as we are moving to the procedure, take a look at the model used for illustration. But before moving to the procedure, we have some calculations to be done. We have to find the TMS of relay A shown in model. To find this, first we have to find the operating time of relay B. As the data for relay B, we have the CT ratio, TMS value, and pickup current value. Since we know the CT ratio, we can find the fault current at relay B. Then, using that value, we can find PMS of relay B. Then, using this equation, we can find the operating time of relay B. Then, we are moving to relay A. As the data, we have CT ratio and time discrimination. Time discrimination means the operating time difference of relay A and B. So we can find the operating time as follows. Since the circuit breaker at B operates first, we have to take the fault current as 2800 amps. So now we can find the fault current in secondary of CT in A. Then we can find the PMS value. So we know PMS and operating current, and we can find the TMS value of relay A. So the TMS value is approximately 0.6. Now we know the sufficient theory for practical. So let's operate the overcurrent relay. This is the inverse overcurrent relay used in the laboratory. You can see the time dial setting and the flag. Value of time dial setting can be adjusted by rotating it. This is the plug multiplier setting. It can be adjusted using these 7 tabs. The other apparatus used in this practical are transformer, variac, ammeter, and rheostat. Let's connect the circuit in figure 4. Observe the primary side of transformer connections. From the variac, it is connected to the rheostat. And then the transformer to reduce the voltage. Before moving to secondary side connections of the transformer, let's identify the relay terminals to connect the circuit. This is the rear view of overcurrent relay. Terminal 9 and 10 are used to connect with the circuit, while terminal 3 and 4 are used to connect the timer. We will be using a stopwatch during the practical instead of a timer connected to the relay. Secondary side of transformer is connected to the inverse overcurrent relay. From the transformer, it is connected to the overcurrent relay. In series with an ammeter. Pickup value. First, power up the circuit and increase the various output. Keep overcurrent relay setting at 2.5 and time setting at 0.5. Start to observe the relay operation. You will notice that at lower currents, relay is not operating. In the instant that relay disc starts rotating, stop the increment of various output. Take down the ammeter reading. This is the pickup current for the relay approximately. Further observe the relay operation. Relay takes a certain time to operate the flag. This is the operation time for the pickup value. Wait until this comes back to initial position before you operate the relay again. Operating characteristics. Obtain operating times for current starting from pickup to 6.5 amperes. First, power up the circuit. Increase the various output until ammeter reads less than pickup value. Then using rheostat, set the current value to 3 amperes. This is a higher current than pickup value. Therefore, relay will operate. After setting the current value, turn off the circuit. Make sure the time dial setting is 0.5 and current setting is 2.5. Set the flag into original position. Now you are ready to take down the operating time. Apply power to the circuit and at the same time start the timer. Stop the timer when relay operates. Note down the time. Repeat the procedure for the current values given in table. Take down the operating times. Plot the graph of operating time versus current for time multiplier setting of 0.5. Time adjustment. Change the time setting to the value calculated for relay at A without changing the current setting of 2.5 amperes. You then obtain the pickup value for new setting by repeating the procedure of previous time setting. Operating characteristics. Obtain the operating times of relay from the pickup current to 6.5 amperes for the new setting. Here, operating time is counted for 3 amperes. Plot the operating time versus current curve for time multiplier setting of 0.6 in the same graph. Write down the answers to the discussion. This is the end of the practical. Thank you very much.